When we're looking at sequences, we're looking for something we call a common difference, or a constant of change, or a slope. So we start with making a t-table. And the t-table consists of term numbers, which I call x, and range numbers that I call y. The term numbers are just 1, 2, 3, and 4. And the range numbers are what's given to us. So in this case, we have 8, we have 15, we have 22, and we have 29. Now what I want to do is I want to look at term 1 and term 2, and I note that they differ by 7. So my question is, do the next terms differ by 7? And if I take 22 minus 15, I get 7. Again, I'll check, and sure enough, from 22 to 29 is 7 more. So what I'm going to start with is I'm going to write y equals 7x. I take that constant of change and I put it in my slope-intercept form as my slope. And I'm going to write plus b. I don't know what the b is, but I can find out. What I'll do first is I'll take the first number and I'll go 7 times 1, that first term. And then I'll add something to it to get to the output. And in this case, if I go 7 times 1, I get 7. And then if I add 1 to it, I get to 8. So my b that I was looking for is 1. So I write the equation y equals 7x plus 1. I'll check this on my second term. If I go 7 times 2, I get 14, and if I add 1 more, I get 15. This is a formula that's going to work. So first off, I want to state that yes, it is an arithmetic sequence because it has a common difference. The equation is going to be y equals 7x plus 1. A more appropriate way to write this might be f of n equals 7n plus 1. Now if I want to find the ninth term, I'll do f of 9. And that's going to equal 7 times 9 plus 1. That's 63, and 1 more. That's 64. Let's look at the second sequence. If I put it into a t-table, label it 1, 2, 3, and 4, I'll have 1, 4, 9, and 16. I'll take a look and I see that 1 goes to 4, that's 3 more. And then 4 goes to 9, that's certainly not 3, that's 5. This is not an arithmetic sequence. And therefore I am unable to find the equation of the nth term, and I cannot find the nth term either. Let's look at the final sequence. -8 to -13, that's a difference of -5. And then to -18, is that a difference of -5? Yeah, if I subtract 5 more, and then if I do it again, I'll get -23. So yes, this is an arithmetic sequence. It's changing by 5 every time. So I'll write y equals -5x plus b, and I don't know what that b is yet. But if I go negative 5 times 1, that gets me to negative 5. And from negative 5, how do I get to negative 8? Well, I add negative 3 more. So let's put negative 3 in for b. Let's check to make sure it works. Negative 5 times 2 is negative 10, plus 3 more is negative 13. We've got a formula. Or I'll write it in function notation. F of n equals negative 5n plus a negative 3. Now you could, of course, write that as minus 3. I just like to keep it in slope-intercept form. Let's find f of 22. Oops, I messed the 2 up. That's better. And that's going to be equal to negative 5 times 22 plus negative 3. 5 times 20 is 100, and 5 times 2 is 10, so this is negative 110 plus a negative 3, which is a negative 113. One more time. I look for a common difference every time. Is it happening the same? If it is, then yes, it is an arithmetic sequence. If it's different, it is not. Once I have that common difference, I write it as the slope in my equation, and I find out what b is. In other words, I go the slope times the first term, and how far do I have to go further to get to the output, and I determine that. Now I've got my equation. This is in slope-intercept form. I write it in function notation. F of n equals negative 5n plus negative 3. And then I use that evaluation, or that equation, to put in the 22, or the value that's asked for, and I determine the outcome.